Here we're going to be learning about direct and inverse variation. This is actually something that you've been familiar with. Direct variation, you're definitely familiar with. It's basically just any graph that passes through the origin. The slope can change, but as long as the y-intercept is 0, that's direct variation. You also saw that last year, probably the year before that even, as proportions. Any proportional relationship is a direct variation. Inverse variation is going to be something that's, before we get into that, we're just going to talk about slope in general. So we're going to try to graph this first line. This has a y-intercept of 4. When we have direct variation, it's going to have a y-intercept of 0. So I'm going to start this graph at 4, and it's going to have a slope of -2. So that means every time I'm going down 2, that's my rise, and over 1 spot, that's my run. So down 2, over 1, down 2, over 1, down 2, over 1, and you can keep doing that. That makes my graph there. On the second one, on 2a, we are looking to find the slope between these 2 points. That's the equation. y2 minus y1 over x2 minus x1. It represents the exact same relationship here. It's still just rise over run. It's just phrasing it in a different way. We're just subtracting instead of counting. So I'm going to do y2, -7, minus y1 over x2 minus x1. That equals -9 over -10. Or if I simplify that fraction, 9 over 10. Negative divided by negative is just a positive number. So I just leave that as positive 9 over 10. The last one, 2b, is looking for the slope of that equation. I'm just looking for the slope, which, if I'm dealing with an equation, I really want to see this in slope-intercept form, so that I can really just read the slope from that equation. It's just a number that's in front of the x. So I'm trying to solve that for y. I want to get y completely by itself. So I have to cancel out this 7x first. I have to get rid of that 7x by subtracting 7x from both sides. Gives me -8y equals, I'm going to put that -7x in front, just so I have it in the right form. Y equals mx plus b. It's almost in that form, but y needs to be completely by itself, so I need to get rid of the -8 that's being multiplied times that y. I'm going to do that by the opposite operation, which means I'm dividing by -8. Divide everything on the other side by -8. So that gives me y by itself. Then I divide -7 divided by -8. That's a positive 7 over 8. I'm just going to change that the same way I changed this one. And I'm also going to do that division. 64 divided by -8 is -8. But that's not really what we're looking for. We're just looking for the slope. So really here, it's 7 over 8. 7 is our slope here. What we found on each of these, this, and the 7 over 8, that slope, we're really going to call that, in variation equations, we're going to call that the constant. We're going to talk about that a lot. For at least the direct variation, the slope is the constant that we're going to be talking about. Variation in general is just talking about how 2 variables relate. It's just the relationship between 2 changing quantities. This is going to be a general description, not a definition for each of these, for direct and inverse variation. In general, at least when we're dealing with positive numbers, as one variable increases, the other variable also increases. For an inverse, it's the opposite. As one variable increases, the other one is going to decrease. Okay, actually, let me just explain what I'm talking about there, just in general. For a direct variation, if one increases, the other increases. It's a proportional relationship. You've learned about this before. Let's say, actually, let's use a picture here. Let's say this is 8 inches and this is 6 inches. If I change the size of that, there, let's say I doubled this became 16. If it's a direct proportion, that means this also doubled. If that's being multiplied times 2, then this one's being multiplied times 2. So that would have to be 12. Inverse works differently. Actually, it's not really possible to show that with a shape. Inverse, good inverse relationship is talking about maybe the number of workers that we have and the hours that it takes to complete a job. Hours of work. So let's say I have 2 workers and it takes 10 hours to complete that job. If I double the workers, if I multiply that times 2, making it 4 workers, it's not going to take twice as much time. It's going to take less time. It's actually going to get divided by 2. So as this number goes up, I'm going to call that my x here. As that goes up, my y is actually going to decrease by that same factor. It's going to be divided by 2. It should take 5 hours. This is an inverse relationship because as this one increases, this one decreases by the same factor. The shape example is direct because as that increases by a factor of 2, this also increases by a factor of 2. So there are 2 specific equations that we use to describe these. For direct, it is what you've seen before as basically y equals mx plus b, where this is the slope. We just happen to have a y-intercept of 0. This constant, this k, is the slope. Another way to write that is just by solving for k, getting k by itself, which means I would cancel out the multiplication that's happening there by dividing. So that would give me y divided by x. The constant can always be found using y divided by x. Inverse is different. It's the constant divided by the x. So y equals k over x. We don't really have a slope here. It's actually going to be a curved line. We'll see that in a second. But we don't have a slope like we do on this one. To solve for k, I would multiply. Right now I have division by x, so if I wanted to get k by itself, I would multiply by x. That would give me y times x. So the constant is always found by multiplying y and x. The graph of a direct variation is something that you've definitely seen before. I'm just going to graph these points, -1, 3, 0, 0, 2, -6, 1, -3, and -2, +6. Oops, I messed that one up, sorry. 2, -6. That gives us that straight line passing through the origin. That's really important about a direct variation. It always passes through the origin. An inverse variation is going to look very different. It's actually going to be 2 curved lines. I'm going to plot, so I'm just going to plot the positive ones first. 2, 2, whoops. 1, 4, and 4, 1. It's making this curved line. On the negative side, it's going to be almost the exact same thing, just completely flipped over. -2, -2. We're also going to have -1, -4, but I'm going to add in an extra point, also -4, -1. It's going to be a similar curved line, except in the opposite corner. That represents an inverse variation. It always avoids the origin. I just gave you a couple real-world examples, a proportional shape that I showed you before, that becoming that. The time you spent studying is proportionally related to your grades. So as one increases, as this, really, the relationship here is between the length and the width. As this length increases, the width increases. Got the colors here, but that doesn't matter. The other classic example of an inverse relationship is our number of workers and the time spent working. As you split up a task among more people, you have to spend less time individually working.